Hello, and welcome to today's webinar on data lakes and business agility. I am Valentine Conan, director at NEOS, and I will be your host today. Before we start, let's go through some housekeeping items for today's webinar. We will be running a live Q&A at the end of the webinar, and we have enabled our Ask a Question feature. You will find a Q&A button on the right-hand side of your screen, so if you have any questions, just write them in there. Please note that the recording of this webinar will be shared with you after the presentation. We will also answer individually to any questions if we run out of time for the Q&A session. In this webinar, Gabrielle Guimont will share with you the foundations of a data lake and how it can impact your business. Gabrielle is passionate about data and has over 10 years of experience in business intelligence and data science. Gabrielle supports NEOS clients, guiding their strategy and decisions regarding data, particularly in the context of data architecture and data engineering. Without further ado, I'll now turn it over to Gabrielle. Gabrielle?
Thank you very much, Valentin, for the introduction. And it's my turn to welcome you to today's webinar. So today, as Valentin said, I'm gonna give you more information about how a data lake increase your business agility. So let's take a look on today's agenda first. First, we will give some groundwork about a definition of a data lake, and we're going to have a discussion about its origin as well. Also, we will see why the data lake is so popular today. We will detail some business scenarios that are using data lakes and where it stands in an enterprise data architecture. Second, we will add some technical details as well, like the zones in a data lake, which data format you can use, and their advantages and disadvantages, and how to interact with the data in your lake. Third, we will make some links between a data lake and a data warehouse, so how the two can coexist and how they work together. Fourth, we will detail some security and governance elements like access management. Fifth, we will present 3 technologies available in the market to play the role of a data lake. Finally, we will conclude with some myths and best practices that will resume what we cover during this webinar. So let's start by the fundamentals, by a good foundation with a definition of a data lake. So on the screen, you see that a data lake is a single repository that contains data in raw and transformed formats, which is used for reporting, advanced analytics, and machine learning. It's really important to remember that it's not only the raw data that is stored in the lake. We will see further in the presentation how we can divide each piece of data in those different zones. During this webinar, please note that I will use 2 terms as a synonym for a data lake. They are data depot and data reservoir. So let's get back to the past a bit, and let's see how the data reservoir is born. One of the principal problems with classic database is really the work in silos between those different systems and the difficulty to have all the information and data in the company into a single location to easily consume it. The data lake can really help in that regard. The term comes from James Dixon, who is a former CDO of Pentao. Pentao is a company that provides business intelligence and big data solutions. He has a really great quote on the subject that compares the data warehouse to really a water bottle ready to be consumed and easily and really quickly. The data reservoir, on the other hand, is a really large body of water that is filled with several different sources, and it can have different use as well. So we can just examine the surface of it. We can dive to get more information about the subject, or we can also take samples, for example, to test the data quality. To encourage the rise of the data depot, there was some technologies like HDFS, Hadoop, and MapReduce that really facilitate the consumption of large amount of data. HDFS use writing on disks to do the calculation. Today, we really favored memory-based solution to process data, like Apache Spark, for example. Finally, also the cloud made data depot initiative much more easier, because today you can start your lake initiative by renting some infrastructure to those cloud companies. So you don't need to host this big infrastructure is in your walls. And obviously, this if you need to do that, that's going to cost a lot of money to spin and to maintain as well. So now that we have a good ground on the data on the lake, let's see some example of data architecture and some business case also that take advantage of the lake. The goal here is really to give you some business problems examples and how we can solve them with a data lake and how this lake fits into the global business data architecture of a company. The first example here is really focused on how to improve your analytical environment and your data warehouse as well. So if we start on the left, right there, so we have the different sources that are used to get into the lake. So how this information gets into the lake is via a data copy tool. So we just get the data and send it to the data lake at its raw form. So the lake can take different data formats. So we can take complex logs for your application or your infrastructure. You can even take some media as well, some photo, videos, and so on. You can use files as well, so files that you have in your file system. The data lake can handle that too, and the lake can handle data from business applications. So data that is usually in relational database, the lake can handle that too. After the reservoir, we can find two different outputs. So we have a top output right there and a bottom output. So let's take an example in retail. So at the bottom, we have the really classical data warehouse example. So we have some ETL process that the source is the lake. The data goes into an enterprise data warehouse, and we have some dashboards and reports that are connected to this data warehouse. At the top, let's say that the retail company wants to build a really simple recommendation engine to facilitate the decision making about future purchase for their website. So we are using yesterday's sales, yesterday's visits, and search on the website to build a really simple recommendation engine, so that we do on the data preparation side. We put the results of this recommendation into a NoSQL database for speed and for speed of gathering the information. And after that, we have a web application that people from the purchase department can use to really get some great purchase, so the customer can have the product that they need at the end of the day. With this architecture that includes all the data of the organization in a single location, you have also an environment to test and experiment your data before adding it to your data warehouse. So that really speeds up the development process of your new facts, your new dimension, because the data is already ingested somewhere. So this is a really great improvement in the agility of your development cycle. Let's dig into our second business case. In this one, we have some data that needs to be followed in real time. For our example here, let's take a manufacturing company that use sensors or Internet of Things device to on their machinery equipment to follow their production level and to estimate when the machine will need some maintenance. There are some differences with the previous model. The first is really the ingestion platform, so how the data goes into the lake. In this case, we are using a streaming processing platform like Stream Analytics for Microsoft, but there is a lot of different other tools as well on the market. So we are using that instead of the copy data because this tool usually uses a trigger with a schedule and not really in real time. So again, the output is divided in two paths. So in the world of real time, we call those paths cold and hot. At the top of the diagram, you can find the hot path right there. So in our example, let's say that the maintenance team use a mobile application and they receive alerts to send crew members to do preventive maintenance on a piece of machinery that is going to be defective maybe. So another advantage here of the data lake, it really allows you to speed up your decision making by leveraging real-time data. At the bottom of the diagram, what you find is the cold path. So the cold path, the goal of the cold path is really to accumulate data to store it for further analysis. For example, to compare the production level of the machine over time. And the other advantage as well is usually your stream processing platform will process the data every 1 to 5 seconds, whatever you manage it. But in your lake, you can store the data at a higher level. So maybe you just need 5 minutes or 10 minutes and so on. So you can play here with the level of granularity of your information. The data lake allows you that too. So you have two different types of granularity, one for your hot path and the second one for your cold path. Now our last business case, use artificial intelligence and machine learning to leverage data from your data reservoir. In this architecture, we use a machine learning service to operationalize a really complex machine learning model. Please note that the machine learning model can be consumed via other methods like a REST API, for example. For this business case, let's take an airport that predicts the number of passengers and visitors that will enter the airport and help to better allocate traffic at boarding gates. So the application is right there at the end, the application for the boarding gates. And let's say that the machine learning model use the information of the tickets sold, so on some business app, and it's going to use some video cameras that on parking lots and at the entrance of an airport, so we really can blend those two together, put it into the data lake, and add it into our machine learning model as well. Finally, the data lake is really suited for a lot of different business cases, like real-time data, use of machine learning algorithms, improvement of your actual data warehouse, and use of real-time application. So really, the data lake can be used in different formats or can handle different business problems as well for your company. And you can easily integrate it according to your informational and decision needs. So let's talk about some technical question about the reservoir. The first one here is about the different zones you can leverage. First, I want to mention that there is a different school of thoughts about the subject. The first zone, the most evident, is the raw data zone. So in this zone, you will find obviously data at its raw format, so without any modification. The access to this zone is usually forbidden to end users. The second zone is the master data zone. In this zone, you will find reference data like lookups or information that does not change a lot in your company. The third zone is the archive data zone. This is data that your organization keeps for reference or to comply to data retention policies. And it's important that it's not used at a regular basis in your organization. What we need to remember is the lake really keeps data perpetually. This zone is really useful to store data at a lower cost compared to usual database products. The fourth zone is the analytics sandbox. In this zone, the data has been already cleaned and is ready to be used for experiment and data exploration. The data can be cleansed, merged with other source, or simply anonymized or masked, like information that is personally identifiable, that is not really useful for analysis. The last zone is the curated data zone. This zone can have multiple use. First, this zone can mimic your data warehouse to facilitate the delivery of the data in this system. Also, you can target another system like a real-time application, as we saw before. Finally, the results of the experiment that are done and ready for production in the analytics sandbox can be sent to this zone. Also, your raw and curated data zones, usually the two biggest ones in your lake, can be also subdivided in smaller zones. Those zones can be divided by business area, by information sensibility, or also by time horizon. So you can have a division by month, year, etc. So it really gives you a good flexibility here on how your data is stored into your lake. For the people that are more visual, here is a good resume on the data flows between those different zones. So obviously, all the raw data goes first in the raw data zone, and the master data goes into the master zone. Both of them goes to the curated zone when they are ready to be sent to a final destination. Here we have a data warehouse, but it can be directly reports, it can be a real-time application, it can be whatever you want at this serving layer point. Also, the raw data goes to the analytics sandbox. So your data analyst, your data scientist can do machine learning and so on. This is really their sandbox when they can play with the data. When some of the algorithms are ready, they can be sent to the curated data zone and after being used in a data warehouse or in reports directly. The last zone is really your archive data zones. So this zone is really, really interesting in a point that it can it can really send some old data in from the data warehouse to this archive zone. So you really relieve your data warehouse of some data that is not used a lot in it. So you can even gain some performance back for your data warehouse too. And you're gonna store this data at a cheaper cost as well. Now let's go into more details about some file formats and also their advantages and disadvantages. Because even if a reservoir can have any type of file format, they really don't react the same when they are written or read into the lake. Let's begin with the CSV format that we are all used to. This format uses delimiters to determine the end of the line or the end of the column. They are usually really easy to read and understandable, but they can be really difficult to manage when with a complex data structure. For example, in my case, I had a lot of headaches because of line breaks in the data or delimiters. So this format has some limitation. The next one is the JSON format. The JSON format is really more modern and used a lot in applications that leverage REST APIs. It's often the format that is returned when we call those applications. This format can handle complex data structure like multiple phone number for an individual, like a personal phone number, mobile phone number, office phone number. It's really great to handle those kinds of cases. The structure is repeated. That can be a bit more difficult to read. The third one is the ORC files, ORC, which are used in Hadoop and Hive ecosystems. Those files are structures in column with a really good compression level. But once the file is created, there is really no way to modify it. You can bypass that by creating a new file but with the original file and the change you want to do with that file. But you cannot modify the first one directly. The fourth one is the Parquet file. It's also a columnar format with a really good compression level like the ORC format. The really big advantage of this format is the reading speed, but the writing is a bit slower than other formats. The last one is the Avro format. It works in line like JSONs and CSVs. This format uses JSON to define the schema of the file. You can really easily modify the file, and also the reading is a bit slower, but the writing is really fast. So with that, it's a really good candidate for your raw data zone because the writing is so fast. Now it's time to dive into how to interact. We put all the data in here, how to interact with the data we put there. First of all, interaction can be done in several ways. You may want to add some new data in your lake. You may want to interrogate that information like we are doing in a database, or what you may want to do is to move data between zones. So you may want to extract it, transform it, and load it into a new zones as well, or directly in external system. First way to interact is the USQL language. It's really an interrogation language built for data reservoirs, like SQL is built for databases. We may also want to use APIs from different programming language. This technique is usually used to load new data or to do some really simple and precise interrogation in the lake. Our end users can also use reporting applications like Tableau or Power BI to read this information. In that case, it's really important that your data is well structured so your end users know exactly where to find the information they are looking for. So it's important to leverage those zones and those subzones as well. We have also some really great technologies like Sparks and DataBricks that are very solid tools to analyze and transform data as well. Those tools will load data in memory and do the transformation in memory as well. So it's really, really fast. They can send the results of those transformation analysis and even machine learning into a new system or another zone. And speaking like Azure, Microsoft, that allow the user to interrogate the lake directly via SQL language and load data directly into a fact table. So this is really interesting, and that's a good way to use a data lake because usually our business intelligence developers really master the SQL language. So it's a really good way to reuse the skills you already have on your teams. So speaking of business intelligence, let's talk a bit more about the link between business intelligence and data lakes. First of all, it's really important to understand that the reservoir does not replace your actual business intelligence environment, like your data warehouse. Like we see in the business case and the data architecture part of this webinar, we saw that it's possible in the same architecture to have data lake and data warehouse together. But they don't have the same objectives and feature. And to be honest with you, those objectives and feature are really complementary to each other. So the data warehouse on its side allows structures and transform data only. And the lake is really much more flexible because it can handle structured, unstructured data, as well as raw and transformed data as well. The reservoir can hold different file formats like image, videos, and files. Let's keep in mind here the image from James Dixon of the data warehouse is a water bottle, and the lake is more a body of water. Also, to put new data in the lake, it's much more easier than do that into a warehouse. But it's the opposite for data retrieval. Why? Because of their data structure. The reservoir have what we call a schema on read. which means that the structure is determined only when we want to consume the information in it. For the data warehouse, it's a schema on the right, which means that the structure is determined when the data enters it. The schema on the right is really more precise and fast, obviously when it's structured correctly, when your table is structured correctly. But the read schema on its end is really more flexible and allow any type of data, and it's really resistant to any change in the schema, like adding a new column, for example. Now that we know the data structure, I really like to come back a bit on the data lake zones. Why? Because, again, your lake allows you a lot of flexibility because you don't treat your zone the exact same way. In your raw data zone, the goal is really to write fast some new information. You really want to do it really fast, like you are doing in a staging table in the database, for example. In the curated data zone, the goal is to make the data discovery really easy. So in order to achieve this, you may want to denormalize information to make data analysis easier for data analysts and scientists. Finally, the lake is really used for ad hoc requests from the business, and the data warehouse can answer predefined questions using measures and dimensions that are visualized via reports and dashboard. But what about those ad hoc requests? This can be questions that the business don't ask regularly, but when they ask it, they need the answer right now. So in this case, the data lake is really great because you already have all this raw data available to answer those questions. In many cases, a really fast exploration of all this raw data can give you the timely and the needed information to enable a really important decision. Instead, before, what we were doing is to build a really complex dimensional model that takes a really long time to build. The data reservoir allows to organize data at a really lower cost, and it's really focused on data consumption. Your user can easily find the information thanks to the different data zones and subzones as well to answer fast their different questions. They don't need to wait for an IT department to do a really long development because the data is already accessible. Remember that the both of them, the warehouse and the lake, really work hand in hand, and one does not replace the other. Let's jump into a really hot topic when we are talking about data lake. This is security and governance. It's easy to think that because you have all the data in the same place, you don't have any security. It's quite the opposite, because the data lake is a really core element of your architecture. You really need to secure it well. A data lake can be really similar to a file server with folders, and in each of these folders can have a different access level. So the information can be really different. It can be anonymized or transformed between those different zones, as we saw before. So the access can be different as well. So because this asset is very important for a company, it holds all your data, you need to have good layers of security. So here is 3 examples of those layers. The first one is the platform access. So we want to separate the authentication, so who logs in, and the authorization. What are the access and rights that this person has? And don't forget about the service accounts as well, that you will need to move data between zones and load it as well. Also, we have network access, so firewall to limit access in your network only, for example. And then in the cloud services, you have also some virtual networks that are available. The final layer is the data protection, so encryption at rest and in transit to really ensure that if the physical server is accessed or if your transaction is cached on the network, you really have some protection in here. The data governance is really another big topic. when an organization used a data lake, a data catalog became almost mandatory. You really need that because it's going to become a navigation map for your users to navigate into all the data that is contained into your reservoir. We really need to know where the data is coming from, what is the source, how it's been transformed, and how it's moved in those zones, and what is the destination at the end. This documentation is data lineage and really explains the whole life cycle of the data in your lake. The metadata is also really important. It's really the information that it's collected when the source is ingested in your lake. To make the process easy, we really need to automatize the collection of the metadata, like the source, the time of retrieval, the number of records, and so on. We can use some different methods to get this metadata, like build really the directory of your lake is your metadata. So you can have your source, you can have the time of retrieval, and so on. Or you can have a file near your source, near the data in your lake with the metadata as well. This is another solution. Finally, with some cloud product, we can identify some sensible data and take automatic action like data masking and anonymization. Here, the goal to remember about security and governance is really to democratize the access of the data with your lake, but while respecting the rule of governance and security as well. Let's jump into some technologies. We will cover 3 of them. We will cover Amazon, we will cover DATABRICKS as well, and Microsoft. So let's start with Amazon. Amazon offers has 2 different offers. The first one is the Amazon Simple Storage Service, or S3. Can allow a company to really easily build the data lake. The second service is a turnkey service named AWS Lake Formation. This service offers other options like data collection with AWS Glue, which is an ETL product. Also, Amazon offers a data catalog that automatically detects sensible data, and also it can detect duplicate data as well in your lake. And it offers excellent security and audit for data access. Let's continue with DATABRICKS, which offer a really different flavor of data lake, the Delta Lake. This is an open source layer that adds to your existing lake. This layer allows ACID transaction like a database. And also the Delta Lake is compatible with Spark. So as we say before, Spark will do transformation in memory, so it's really, really fast for transformation. And the great advantage of this technology is the table versioning. So if you use in the past temporal table in SQL, it's really similar. Or if you use any version control like Git, the feature is similar too. This means, if you don't know those technologies, that you can see all the changes in a table and in your data, and you can revert those changes individually. Finally, the Delta Lake from DATABRICKS mainly use the Parquet file format. Let's finish our technology overview with Microsoft, who offers Data Lake Storage Gen 2, which is their most recent tool. This tool is built on Azure Storage. Therefore, your lake can be replicated in many regions to increase the durability of the solution, and it's evolutive because of the seamlessly infinite amount of space available. This solution allows you to manage big data scenarios, so you can really load big quantities of data in a short amount of time. There is also the hierarchical namespace that allows a really fine and precise management of your access via the access control list. The integration also with other Microsoft tools is really simple. Whether we talk about reporting with Power BI, data movement with Azure DataBricks, or your data warehouse with Azure Synapse. Finally, the security is also strong with encryption, access limitation via firewall, virtual networks as well. So we saw 3 different cloud technology here. The cloud really allows you at a lower cost to create your data reservoir, which can be really difficult and costly if you want to build that on premises. Also, the cloud allows you to scale up really easily. So if during a really brief period of time, you need more resources because you have a spike in use and in your users, you can really change the capacity of your service really easily with those 3 services. It's a really big improvement the cloud gives you. So before jumping into the conclusion, I want to share with you some tips and tricks on how to start your data lake initiative. Let's, like we saw in the data lake and business intelligence portion, the lake and warehouse don't fill the same goals. So it's really important to ask if the lake is a good solution for you. If your company wants to leverage real-time, use machine learning, or ad hoc analysis, the lake is really a good solution. Start your project with really small proof of concept with really specific objectives. And here is 3 examples for those objectives. The first one is if you work with data that is really difficult to integrate in your actual environment. So like photos or videos, the lake is a really good place to start. Also, you can use your reservoir as a staging for your data warehouse, or you can decrease the load of your data warehouse by using your lake as an archive for it. So you will reduce your cost and improve the performance of your warehouse. Also, think beforehand how you want to structure your zones and subzones. This is a really critical step. So you can use this planning to start your catalog and data lineage documentation. So it's really important to know which type of data will go where and how this information will pass from one zone to another and how you want to build your subzones as well. Final thought, and it's really the most difficult here, is find the right balance between the agility of bringing new data in your lake and a rigorous technical implementation. The answer here will vary from company to company, but it's really important to think about it and have a good reflection on this question. So let's finish with our myths and best practices. Here, we will review mainly the main point I want you to remember from this webinar. So the first one, you already hear it a lot, but a data lake does not replace your actual business intelligence environment or your data warehouse. The goals and feature of the reservoir is really an excellent complement with those of a warehouse. The second one is your data lake is not just here to store your data. Think of it as a conceptual data architecture with your whole data lifecycle in your company. So this is possible with the different zone, with the data catalog you build, with the data lineage you created as well. And speaking of those zones, another myth is that you only keep raw data in your lake. But we saw with the different zones that your reservoir can leverage those zones to serve that data at different purposes and different use cases as well. Final myth is about security. Really, since all the data of your company is in it, it's really easy to think that there is no security in there. But since the really importance of this asset, it's really important for you to secure via the 3 different layers, and also to be sure that the zones in your lake are access to the right people, and that you do the right transformation between those zones as well. If you want to dig deeper, if you want to go further, here is some links that you can check on your own time. And also don't hesitate if you need some help to setting up your data lake. Really want to thank you for your attention today. Now it's our turn to listen to you. don't hesitate if you have any question. It will really be a big pleasure to answer them.
Thank you, Gabriel. And yeah, like Gabriel mentioned, you can ask questions on the chat functionality of the window open on your browser. So you should be able to ask questions on the right, and I'll see them and publish them. While we wait for potential questions to trickle down, I had one question for you, Gabriel, to start. What would you say in terms of is a data lake for everyone, like in terms of company size, for example, or in terms of data available? Like, is that something that any organization could use?
Yeah, totally. First, that's a really great question. And what is great about the lake is flexibility. You can use it at a different purposes. So as we saw, we can use it in a classical business intelligence environment to get your old data to go into your lake. So you're going to save cost. And at the end of the day, your data warehouse will have less data in it, so can be more efficient as well. So you can use it in that way. You can use it in a really big and complex machine learning scenario. So it's really the interesting thing here. And usually you don't think about your data lake to be really big at first. You really start small and you add layers on it. So, and with the cloud as well, with the cloud, usually you pay as you go. So you pay as the amount of data you have in it. So you can start really small with not a lot of cost and to improve the solution brick by brick. So this is really the big flexible part of the lake. You can start small and improve it.
Mm-hmm. Awesome, cool. And you've touched on something real interesting. You talked about cost effectiveness. Can you share a bit more about that on that front?
Yeah. So yeah, I touched it a bit. So it's really linked to the cloud. So in the cloud, you pay as you go. So you pay with the amount of information you have in your lake. So if you have a 3 terabyte, you will pay only for those 3 terabytes. The very big interesting thing here with the lake is you separate your storage and your the transformation of your data. So how you will transform your data. Usually storage is really cheap. So if I just want a disk to store my data, this is cheap. But if I need really big clusters of computers to do some transformation to prepare my data, this is really much more expensive. So with a data lake, you separate the two. So you have your storage that is always on and it's cheap, so it's fine. But when you want to transform that information, usually you don't want to transform it all the time. You have some batch processing and so on. So your lake really separates the two. And usually when you have a database, you have the two stuck with you. So you don't have the choice to have storage and processing at the same time. But the lake allows you to separate the two and spin processing only when you need it. So you may have processing only for 2 hours. It's going to cost you a lot, but really less than if this processing runs for the 24 hours in a day.
All right, awesome. I guess one of the key words from today's presentation and answer to the question is really flexibility from what I hear, both in terms of, like we said in the title, business agility, but also in terms of cost effectiveness. Well, I don't think there's any questions, but I just wanted to let everyone that if you have any questions, feel free to share that by email with us. We're always happy to answer to any questions you may have, and we can also connect on the phone if you're interested in talking more. But thank you, Gabriel. That was great. And thank you, everyone, for joining us today. And we'll be in touch with the recording soon.
Thank you very much, everyone.
Thank you. Bye-bye.